Okay, hello everyone. In a new video, on this one we are going to solve an exercise related to electricity in the chapters of resistors, electric power and energy, AC voltage, and the voltage of the means. This exercise was a previous one in the Brevet exams in 2005 second session, second exercise. The title of this exercise is Circuit Breaker in a Kitchen. The electrical installation in a kitchen is fed by sinusoidal alternating voltage of effective value is equal to 220 volts. Then the applied voltage, which is considered to be the effective voltage, is given by U is equal to 120 volts. This installation includes the following electric appliances: a refrigerator, a washing machine, an electric water heater, which can be considered as a resistor of power P is equal to 1540 watts, an incandescent lamp carrying the following indications: 220 volts and 100 watts. Number 1. These electrical appliances are connected in parallel. Why? So here we must be very careful to this question. So in domestic installations, electric appliances are connected in parallel in order to function independently. So in order to function independently. So by this we can switch an electric component or an electric appliance and turn the other one, and this is the reason why electric appliances are connected in parallel and not because to have the same voltage. Then let's say in order to function independently, now in number 2, part A, they are telling me the lamp functions normally. Why? So the lamp, they are talking about the incandescent lamp. It carries the following indication, which is 220 volt. So in order to describe the functioning of the lamp, we need to compare the rated voltage to the applied voltage. And in this case, the applied voltage is 220 volts. So let's say since the applied voltage which is considered in this case the effective voltage, is equal to the rated voltage of the lamp. So between brackets, 220 volts is equal to 220 volts. Then the lamp functions normally. Now in part B, calculate the effective electric current I1 through the lamp. So the lamp carries these two indications, the voltage and the power. So we can calculate the electric current using the formula P is equal to U multiplied by I. Knowing that we are interested in calculating the value of I, so constructing the triangle of this formula, U will be at the top. Sorry, here because we have multiply, then P will be at the top, U and I at the bottom. We are interested in calculating the value of I, which is denoted here in this case by I1. So it's equal to P divided by U. The value of P in the SI is given by 100, and the value of U in the SI is given by 220. Now plugging this on the calculator, it will give me 0.45. Since everything is in the SI, so the value of I1 will be in the SI, which is amperes. Then the value of I1 traversing the lamp is given by 0.45 amperes. So let me write here that I1 is equal to 0.45 amperes. Now in number 3, part A, they are telling me the effective voltage across the water heater is 220 volts. Why? So here, notice that because all the electric appliances are connected in parallel, as we have mentioned in number 1, so according to the law of uniqueness of voltages, so they will have the same voltage. Okay, so 3 part A, let's say that the water heater is connected in parallel. Then according of uniqueness of voltages, it has, so it refers to the water heater, it has the same voltage, which is given by U is equal to 220 volts. Now in part B, calculate the effective electric current I2 through the water heater. So now we know the applied voltage across the water heater, and the water heater, which can be considered as a resistor, has the following electric power, which is given by 1540 watts. So also using the formula P is equal to U multiplied by I, we can determine the value of I. Now constructing the triangle of this formula, P will be at the top, U and I at the bottom. We are interested in calculating the value of I, which is denoted by I2 in this case, so it's P divided by U. Now here P corresponds to the electric power consumed by the electric water heater, which is given by 1540, divided by the applied voltage, which is 220. Then plugging this on the calculator, it will give me 7. Since everything in the SI, so the value of I2 will be in the SI, which is amperes. Then I2 is equal to 7 amperes. So let me write here that I2 is equal to 7 amperes. Now number 4, knowing that under normal functioning, the effective electric currents through the refrigerator and the washing machine are respectively I3 is equal to 5 amperes and I4 is equal to 10 ampere. Determine the value of the effective main electric current when all the given electric appliances function at the same time. So we need to determine the main electric current, knowing that these electric appliances are connected in parallel. And because they are connected in parallel, then we can apply the law of addition of currents. Then how do we apply this law? Always on the left we write the main current, and on the other side we write the different currents crossing different electric appliances or different electric components, and they are given by the refrigerator, which is denoted by, so let's start by the lamp, which is denoted by I1. So we are done with the lamp. And with the electric water heater, which is denoted by I2 plus I2. And across the refrigerator, which is denoted by I3. And across the washing machine, which is denoted by I4. Now the value of I1 is given by 0.45 in the SI, plus I2, which is given by 7, plus I3, which is given by 5, plus I4, which is given by 10. Now plugging this on the calculator, it will give me 22.45. Since all the currents are expressed in amperes, so the main current will be also expressed in amperes. Then the main current reversing this domestic installation is given by 22.45 amperes. Now finally in part 5, they are telling me we intend to protect these electric appliances with a circuit breaker. Which one of the 3 available circuit breakers rated 25 amperes, 30 amperes and 40 amperes is the most adequate to be used in this kitchen? Why? So here by adequate they mean convenient. And in order to determine which circuit breaker is the most convenient, let's write the definition of the circuit breaker, or the most convenient circuit breaker. So the most convenient circuit breaker is the one having a rated current slightly greater than the main current. So here all of these circuit breakers carries a rated current 25 amperes, 30 amperes, 40 amperes. All of them are greater than the main current, but the most convenient one is the slightly greater than the main current, and this is given by 25 amperes. So the most convenient circuit breaker is given by 25 amperes. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon on another one.